Good evening, everyone. Myself, Somali Haldar. I welcome you all to the classes of education. As you know that I will be teaching you geography. So without any delay, let's begin. In the first class, I taught you regarding the interior of the earth. But the crucial point which I left incomplete was the volcanoes, which I wanted to pick up in details in the successive classes. So in today's class, that is what we are going to explore in details, volcanoes. So let's begin. In the last class, we explored in details about the interior of the earth, and we explored it in the terms of informations or the evidences, whether they are direct source of evidences or whether they are indirect sources of evidences. If you recall, direct source of evidences are those which are in front of us. We don't need something in order to see that. The direct evidences are in front of us and we are able to see that with the help of our naked eyes. Whereas indirect evidences are those which we are not able to see with the help of our eyes. We need to rely on some other information which will give us an idea about the interior of the earth. And let's talk about volcanoes. Volcanoes means what? Where the molten materials are being thrown out. So when it is thrown out, how can I say something is being thrown out? Because I can see that thrown material. Visit any volcanic erupted area, talk to the people, survey that area. You will come to know that what are the problems they faced. They will say that the ashes engulfed the area. They faced a problem where they lost their agricultural land because the ashes, the volcanic materials, they covered the area. How did they say that? Because they saw it in front of them. So that is when it became the direct source of information. So hearing in today's class, we are going to talk about volcanoes. So here I've written volcanic eruption, which is a direct source of information, which is pretty clear to you, I hope, at this point of time. But in today's class, we are going to talk in details about how volcanoes, structure of volcanoes, how volcanoes work, and why the study of volcano is important for a student of geography at any level, irrespective of the fact whether he or she is preparing for UPSC, irrespective of the fact whether he or she is preparing for ICSE, CBSE, or UGC NET JRF Geography. Before delving deep into the details, it becomes very important to talk about the structure of the volcano. Like for example, when we say the anatomy of the body means we have a head, we have our hands, we have our body, we have the toe, which gives it a proper foundation for which we are able to sit. Like I'm able to sit. Why? Because the structure of my body is giving that foundation for which I am able to sit. Similarly, there is some structure, there is some foundation, there is some base which is giving that proper shape to that volcano and it is standing in front of us. We need to explore certain structures, certain parts of it. All right. Let's talk about magma chamber, which you can see in the interior. Magma means the molten material which is found in the interior of the earth. So deep below, when you go towards the lower mantle or outer core, the temperature is pretty hot. The temperature is very hot, for which the materials exist in molten state. Some of it might exist in solid state in liquid mantle. As you know, when the P waves experience an increase in velocity, followed by S waves also, which faces an increase in velocity. So your magma chamber is the chamber or the reservoir where magma or the molten material is being formed. It is being stored over there. And gradually it rises up if there are cracks within that. We will explore it. Next up comes the vent. The vent means the upper portion, not the neck, not the neck. For example, this is the neck. This is our neck. Similarly, look at the volcanic structure. This is also, like, if this is the structure of the volcano, this is the neck of the volcano. What is the function of the neck of the body? The neck of the body helps me to swallow the food, like the food passes through this. Similarly, from here, if my stomach is the magma chamber, the molten material is coming from the neck and then it is coming out. So this neck is that portion where you can see the red line. That entire portion is the neck of the volcano from where the molten material is trying to come out. The portion which is opening, a very narrow opening on the surface of the volcanic structure, that is called the vent. Now equate the vent with our mouth. The lip portion, this portion is our vent. When we say that in English, Tomali is trying to vent out her anger. Vent out her means she is trying to release her anger. She is trying to release her frustration. Similarly, the volcano is also trying to vent its anger in form of ashes, in terms of liquids or in terms of the solid materials. So the vent is the opening, like my lip is the opening, or my mouth is the opening from where the food is coming out or where the food is going in. Similarly, over here also, this structure of the volcano is nothing but the vent of the volcano, which is a narrow opening from where the volcanic materials are coming out. And you can see there are clouds of ash, steam, and the rock fragments which are being hurled into the air from the vent of the volcano. Okay. So if the molten material, if the magma is able to rise through the magma chamber, cross the neck, like topple the vent and come on the surface of the earth, then that becomes the lava. So here it is written as lava flow. All right. Now this is the magma chamber. I'm writing C. Here the magma is being formed and the magma is then trying to rise up. The magma is trying to rise up from where? The magma is trying to rise up from the neck of the volcano. This is called the neck of the volcano. Similarly, like we have our neck, I am repeating once again. Okay, now when the neck, through the neck of the volcano, the volcanic materials are coming out, like there should be an opening from where it will flow out. The opening, this very narrow, which will widen and will give rise to some other structure, this narrow opening from where the molten material tries to come out is called the vent. So let's say if the magma is very energetic, very active, and it is able to come up, what can happen? Because of the force of gravity, it will fall down. It can fall down on all the sides. Give it more time, another set of magmatic eruption comes up. The magma again comes down. I hope you people are acquainted with the structure of an ice cream cone. By now, all of you must have had ice cream. So the ice cream, especially in the cornetos or in the cone-like structure, the cone is something like this. And then the scoop is given, the scoop of ice cream is given on the top. So it's like an inverted triangle. Look here. The cone is somewhat like this only, but like an inverted form of the ice cream cone. But it resembles the shape of a cone. Why? Because the series of magmatic eruption followed by the sloping down of the magma one by one, or sloping down of the lava. These are the lava flows. The series of magmatic eruption followed by the flowing down of the lava flow in a sequential manner has given rise to formation of what we call a cone-like structure. So this is the entire structure of the volcano. All right. As I told you, in volcanoes, we will be exploring several things. So let's talk about the different types of landform. Landform means a shape of the land which is either gentle or which is steep. It can resemble a shape of a mountain. It can resemble a shape of a hill or a plain or a plateau, depending on whatever is happening in the interior of the earth. So that is what we are going to explore here. There are two types of volcanic landforms based on the location. This is based on the location. Intrusive landform, extrusive landform. Go by the word. When you enter a hotel, you use the word enter. N is there. But when you exit the hotel, when you're going out of the hotel, exit, X is there. That means when you're entering the hotel, you're inside the hotel, that is N. There is a word N. And when you're coming out of the hotel, when you're exiting out of the hotel, there is a word X. There is a letter X. Intrusive landforms. Intrusive landforms means those type of landforms which are formed in the interior, in the inside of what? Of not a building, of not a hotel. Those type of landforms which are formed in the interior of the Earth's surface because of something which we will do later on. Extrusive landforms are those type of landforms which are found on the outer surface. Outer surface of what? Hotel, building? No. Extrusive landforms are those type of landforms which are found on the surface of the earth, on the surface of the earth. And intrusive landforms means inside the surface of the earth. So the preposition changes depending on the location. It's very easy. Before I delve into the different types of landforms in details, these two things are very, very important to remember, without which I won't be able to explain and without which you won't be able to remember. Just remember two things. There are two types of lava flow depending on the silica content. Wraith. Two types of lava flow depending on the silica content. So the factor silica is very important. If there is more amount of silica, imagine a volcanic eruption. For example, let's say this is a volcanic, this much is the volcanic lava flow. And within the lava flow, this nose drop is the silica. That means, can I say that the volcanic, this much amount of volcanic flow is carrying the silica with it? Don't you think that the volcanic flow is much more heavy? It's much more denser. It will tend to settle down and it will not be able to flow over long distance because it is carrying it though. There is a pressure on it, which the volcanic flow is not very happy to carry, but still it is supposed to carry because nature has provided it. So in this category, let's say there is too much, this is silica, too much amount of silica is there in the volcanic flow. So this is contributing to the more density of the volcanic flow. This we find in granitic type of lava, when the lava solidifies, it forms granitic rocks. When I will teach you rocks chapter, then you will know in much more details. But for now, remember this. Granitic lava or magma comprises huge amount of silica for which it is not able to flow over considerable distance. Even if it comes out, it tends to stop there. Okay, next category is the basaltic lava. There is only the volcanic flow. There is only the volcanic flow along with this much amount of silica. Along with this much amount of silica. Earlier, there was this much amount of silica. But now I am talking about this much amount of silica. So can I say the volcanic flow is carrying less amount of silica? When the volcanic flow is carrying less amount of silica, we use a word called viscous. Less viscosity. So basaltic lava, less silica, less viscosity. Less viscosity means it is less dense. So when it is less dense, that means the volcanic flow is also very halka fulka. It is able to flow over large distance. But if I give more silica to it, that means it is becoming more bhari, more heavy. It will tend to stop. It will tend to fall down. Why? Because it is more viscous. It will become very inactive and it will solidify then and there. So these two types of lava and magma is very important before I go into further details. This is also very important. Like, what are the materials that are ejected during volcanic eruption? The products are, be it in form of gaseous, be it in form of liquid, or be it in form of solids. Gases, you know, the harmful gases that are being released: carbon dioxide, sulfur dioxide, water vapor is being released if there is water around. In the liquids, the magma that comes out, we call it lava. So the molten material that is being thrown out, that is in terms of the liquid. The solids one is more interesting because there is classification. You can see the diameter I have done. If the diameter, here I am talking about the diameter. If the diameter, that is the size of the particle, the diameter of the particle is less than 4 millimeter, then I am talking about ash. Then I'm talking about ash. And when I'm talking about 4 to 32 millimeter ka diameter ka product, which is solid in nature, we call it cinders. When it is more than 32 millimeter, it is very huge in size. That is when we call it volcanic bomb or volcanic blocks. Bomb means what? It has a potential to cause a great disaster. Similarly, volcanic bomb, when I call it a volcanic bomb, that means I'm telling it with more fear that it will cause more problems. So when we are talking about the solid materials being thrown out during volcanic eruption and they are having a diameter of more than 32 millimeter, this is called volcanic bomb. By the way, I think this portion is not given in the volcanoes part, and the volcano chapter that I'm teaching you is not a chapter separately. It is an inherent chapter of the interior of the earth. So I think you might not find this part, so I thought it will be useful for you if you get such questions on it. Even if you don't, extra knowledge is useful always. Now we equate that granitic lava and basaltic lava with here. Again, I'm repeating since I did one thing in the middle. When I'm talking about granitic lava or magma, there is a volcanic flow, silica content, huge amount of silica content for which the lava is very heavy and it tends to settle down the moment it comes out. And it is more viscous, more dense, more silica, all more in granite. When I talk about basaltic lava, there is volcanic flow. Along with it, there is less silica. There is silica, but there is less silica. Less silica, less viscosity, less dense, for which it is able to flow over larger distance. So everything less in basaltic, everything more in granitic. Okay. Now, why is it important to understand the extrusive landform? Extrusive landforms are those type of landforms which are occurring on the surface of the earth because of the solidification of the lava. Because I'm talking about exterior portion of the earth's surface. Okay. Look at the shield volcano. Don't you see that the lava is coming out and it is flowing here and there? So the moment I talk about flowing here and there, that means it is flowing over a large distance. So flowing over a large distance means it must contain basaltic lava. It must contain less silica. It must be less viscous. It must be less dense, for which it is able to flow over large distance. Okay. So that is what the shield volcano is. So the shield volcano is also sometimes called basic volcano because the basaltic lava in this case is basic in nature. It is basic in nature, containing less silica. And also you can see when it is solidifying, consider the height of the shield volcano with that of the composite volcano. I'm giving you 2-3 seconds. Consider the height of the lava flow of the shield volcano and the height of the composite volcano. Which one is more? The more one is composite volcano. Why? You can see that in the shield volcano, the lava is just coming out. It is not tending to solidify just around the vent of the volcano. It is flowing. It is flowing over a large distance. But in the composite volcano, if I consider this red color as the neck of the volcano and the lava coming out from the vent of the volcano, can I say that the lava is tending to solidify close to the vent of the volcano? Whereas in the shield volcano, the lava is not tending to solidify close, rather it is tending to move or flow over a larger distance. Whereas in case of composite volcano, lava is flowing, but it is not flowing much away from the vent. It is tending to solidify, or it is tending to fall down much closer to the neck or much closer to the vent of the volcano. In composite volcano, this happens only when there is more silica content in the lava, more rate in the lava. When there is more rate in the lava, that means it must be that the lava is very viscous. It is very dense, for which is not able to flow over larger distance, and it tends to solidify very close to the vent of the volcano, thus giving rise to the high rise mountains. So your composite volcanoes, if you're asked a question that out of shield and composite volcano, which one is having a higher height, definitely opt for composite volcano, because in composite volcano, granitic lava comes out. Granitic lava contains more amount of silica. Remember this eardrop wala thing and a mobile thing. Because the granitic lava contains huge amount of silica, more viscous, more dense. Whereas shield volcano contains less amount of silica, less viscous, less dense, flows over larger distance. Okay, I hope it's clear. You can see one lake is there, water body. Out of caldera and crater, which lake is occupying a larger area? Forget the location. Which lake is occupying the larger area? It is definitely the crater. That means the lake is obviously of a smaller size in caldera, and in a crater it is of larger size. Now, why is that happening? For example, let's talk about the cone shape. I hope by this time you know what is the cone shaped volcano. If I talk about the cone shaped volcano, again, this is the neck of the volcano, and this, by this I mean the red portion, and this portion is the vent of the volcano. I'm not writing it repetitively. What I was teaching the crater and the caldera. Now, the magma is continuously upwelling from the magma chamber. It is continuously rising up. So when it is continuously rising up, I'm using yellow color. Can I say that the magma is in direct contact with the lower portion of the vent? It is in direct contact with the lower portion of the vent. So when it is in direct contact, that means the lower portion of the vent will get heated up. It will get heated up and it will melt. So the moment it melts, don't you think from this structure, it will become this, because it is getting melted because of the high temperature. So don't you think, sorry, let's begin, that the structure will be somewhat like this? The cone shape is still there, but the size of the vent increases in size. It becomes more or less like a circular shaped depression. So this circular, more or less, not entirely circular. So this more or less circular shaped depression is what we call caldera. When it gets, like, caldera is not always filled with water. It's just a depression. When there is rain, when the caldera fills with the water, that is when we call it a caldera. So the vent of the volcano, when it is coming in direct contact with the magma, the lower portion of the vent, it keeps on melting. So the moment it keeps on melting, its size goes on increasing. So when its size goes on increasing, the depression increases, and the size of the depression increases, and then that depression, when it becomes much bigger than the vent, then it is called caldera. And when the caldera is filled with rainwater post rainfall, that is when we call it a caldera lake. Okay. Here you can see that the size of the caldera is even more. The size of the caldera is even more than that of what was there in the previous situation. This is A situation, this is B situation, this is C situation. In C situation, the size of the caldera is bigger than what is there in B. So when the size is more than that of the caldera, we call it a crater. We call it a crater. So the crater is always bigger than that of the caldera. Please have a look at this also happens when the crater gets filled up with the water. We call it a crater lake. Now you will say that what is then the basic difference between the crater and the caldera? The caldera, you can see that the shape of the lake is very small than that of the lake in the crater. In caldera, what happens is that the extent of the lake is more or less 1 to 2 kilometers, not more than that. 1 to 2 kilometers. In crater, it can be 10-20 kilometers. You can see for yourself. There is no limit to the extension of the lake in the crater. So when it exceeds 5, 6, 10, 15 kilometers, then it becomes crater. But when the extension is limited from 1 to 2 kilometers, that is when we call it the caldera. And you can see for yourself, I've written it for your information, that the largest caldera in the world is the Ezo lake in Japan, and the largest crater in the world is the Lake Toba in Sumatra Island, which is a part of the Indonesian island. Flood basalts and mid-oceanic ridges, very important. Again, basalt. When I'm saying basalt, that means it must be equated with the lava, which is having less silica, less viscous, less dense, for which it is able to flow over larger distance. Now look at the diagram. Look at the diagram. See for yourself. The red color area is the lava that has covered a considerable distance after coming out from the cracks. The cracks are the orange part. From the orange part, the magma is coming out, it is becoming lava. When the lava with the less silica, it is flowing over a larger distance, that is when it is called the flood basalt. Go by the word flood. What happens in flood? Water overflows from the river and it covers a larger area. Similarly, the magma is coming out, becoming lava, and it is covering a larger area. Why? Because it is having less silica, less viscous, and it's less dense in nature. Classic example is of Deccan Plateau of India. It's filled with basaltic lava. It's filled with basaltic lava. Okay. And the last landform under extrusive landform is the mid-oceanic ridges. Now, you will think that how come it's a mid-oceanic, how come it's an extrusive when I'm talking mid-oceanic? Extrusive means that is found on the crust of the earth. Our crust of the earth can be continental, can be oceanic. That means it can be Sial or continental, or it can be Sima or oceanic. What is happening in the mid-oceanic ridge is that, let's say, this is the oceanic plate. This is the oceanic plate. Why I'm saying oceanic plate? Because the ocean has a bed. The ocean has a bed on which the water is flowing. For example, if I'm saying the river water is flowing, the river water is flowing with the support of the river bed that is inside it, and on the bed only I'm getting the river water. On the bed only I'm getting the river water. So the bed itself is solid in nature. How is it become solid? Because the magma has come out, it has solidified. That we are going to do here. This is the ocean. Now the magma chamber is there. From the magma chamber, the magma is trying to come up. When the magma is trying to come up, at this point it is creating pressure. So slowly, this entire portion is melted. So let's erase this portion. Slowly, this entire portion is melted. Now, when this entire portion is melted, the lava will tend to solidify in the between. So when it is tending to solidify in the between, don't you think whatever is there on the either side, if I am coming in between, I will try to push here. Again, I will try to push here. So whatever is there on the left and the right hand side of this newly formed magma, it gets pushed both left and right slowly. So slowly what happens? A new set of crust is formed. A new set of crust is formed, and the older oceanic crust is being pushed aside, be it left side or right side. So in between the areas, there is accumulation of the lava. So the crest portion of this accumulated lava is what we call the ridge. R-I-D-G-E, not the rift. The rift is the valley which is occurring between two mountainous regions. Here it is not the valley region, it is the crest, the topmost portion. So that means something is getting, something is not like this. This is not a ridge, this is a ridge. They may not be of a higher height like mountains, but they are a sort of mountains only. But they are underwater mountains. That is why they are called mid-oceanic ridges found inside the ocean. So when the new oceanic crust is being formed with the solidification of magma, magma tends to solidify. When the magma tends to solidify, the crest portion, the topmost portion, is what we call the ridge. And here, same thing. Here, because I'm saying that the lava is forming, it is getting pushed. That means you must consider it is getting pushed over a larger distance, considerable distance. So here we also get the basaltic lava. Okay, so composition remains the same. This is your Atlantic Ocean. This entire portion is your Atlantic Ocean, right? This is the very interesting thing. In between the Atlantic Ocean, you will have one line. That line is nothing but what we call the mid-oceanic ridge. And it is along this line where the Atlantic Ocean is spreading. Atlantic oceanic crust, not the ocean, the Atlantic oceanic crust is spreading. Obviously, the ocean which is on the top of it, that is also flowing over a larger distance. We are thinking about the crust which is formed from the solidification of lava. So when it is solidifying and it is pushing aside the older crust, newer crust is formed, older crust is being pushed aside, so newer area is being formed. This is happening in the mid-Atlantic Ocean. Not only in mid-Atlantic Ocean, we also get this in Indian Ocean. And the type of ridge in this Indian Ocean, we call it a Carlsberg ridge. Let me go back. We call it a Carlsberg ridge. Carlsberg. So with here, at this point, we complete the extrusive landform.